In this video, we'll be solving derivatives, but unlike the last video, this time at an intermediate level. So here is the first problem. It states that f of x is equal to x squared times e to the x. So now off to the side, there's actually just the chain rule. Now, yeah, you don't have to use the chain rule for this particular problem, but we'll definitely be using the chain rule for, I think, every single one of other questions. I don't know. We'll see. Anyways, for this first problem, you notice that it is a function here. The first function is just x squared, and the second one is e to the x. Notice that it's just the first function being multiplied by the other. That means we can apply the product rule. Now that states that the derivative of two functions being multiplied, we'll call it u times v, is equal to u and the derivative of v in respect to x plus v times the derivative of u in respect to x. Now we can simply just apply the formula here. F of x is equal to, in this case our u is just x squared, and then it's going to be the derivative of e to the x plus our v is just e to the x, and then the derivative that multiplied to the derivative of x squared. And now we just solve the individual derivatives. Now the derivatives of e to the x is just e to the x plus it's going to be e to the x times the derivative of x squared. In this case, we just use the power rule and we get 2x. And so we get that this is going to be 2 e to the x. Now there's of course different ways to write. I guess this would look better. And you can factor out the e to the x if you want. Depends on your teacher if you're doing this for school. If you're doing this for your own sake, well, here you go. That would be your full solution. Here is the second problem. It states that f of x is equal to ln of 3x squared plus 1. Go ahead, pause the video and try this for yourself first. Now, if you've done that, then let's try to tackle this problem. Now, here, what you instantly notice is that there is a ln. So let's try to recite the derivative formula for ln x. So it's going to be ln x is equal to 1 over x. But we know that we cannot just straight up apply that formula because we have a composition of two different functions. In this case, it's going to be ln, the whole thing, and then we have the whatever's inside the ln. And so we're going to apply the chain rule here. Now what does the chain rule state? It states that the derivative of this composite function, f of g of x, is equal to f prime g of x times g prime x. So the derivative of f of g of x and the derivative times the derivative of g. So in this case, our f of x is simply just the ln, and then our g of x is what is inside the ln. Hopefully you can kind of see that. So if we called, so I know it says f of x here, but if we, let's just say f of x was equal to ln x, and let's say g of x was equal to 3x squared plus 1, well then what would f of g of x be? That would just be this right here. And so we simply just apply the chain rule. So first we'll just get the derivative of ln, which is just 1 over whatever's inside. So our first step in getting f prime of x is just going to be 1 over 3x squared plus 1. And then what is that multiplied by g of x, which in this case is just whatever's inside the ln. So it's going to be times the derivative of 3x squared plus 1. And so here I'll keep this right here, 3x squared plus 1, and it's going to be the derivative of 3x squared plus 1. So the derivative of 1 is just 0 because it's a constant. And for 3x squared, we just apply the power rule. So it becomes 2 times 3x, or just simply 6x. And just bringing that up, it becomes 6x over 3x squared plus 1. And that is f prime of x, and this, there we go, will be your full solution. Here is problem number 3, which states y is equal to square root of x squared plus 1. Now, here I'm going to give you some time to pause the video and try for yourself, and once you've done that, we'll go over it together. So now if you tried the question, it's pretty similar to the last problem in the sense that it is again a composition of two functions. Now composition of which two, you may ask? Well, it's going to be composition of, we'll call f of x square root x, and we'll say g of x is equal to x squared plus 1. And so what is f of g of x? Well, that is simply just square root of x squared plus 1. And so again, we can just apply the chain rule. So applying the chain rule, first we just want the derivative of f of x, or in this case it's just square root of x. So it's gonna be, well, actually first let's rewrite this. Let's rewrite this using an actual exponent. It's gonna be like that. And we just want the derivative, well, actually technically this shouldn't be right here. It's gonna be y. So what can we do here? We simply just apply the power rule. That goes up there, and it's gonna be 1 minus this number. This number minus 1. So it's gonna be 1 over 2 x squared plus 1 to the power of 1 over 2 minus 1. So that is just the derivative of the derivative of f of x. But now we want to multiply that. Well, in this case, f of g of x. But now we want to multiply that the derivative of g of x, which is just the derivative, in this case, g of x is x squared plus 1. Okay? And so we just do that. It's going to be 1 over 2 x squared plus 1, and then it's going to be negative 1 over 2. Multiplied by the derivative of x squared plus 1. Again, 1 is a constant, so that's just going to be 0. And then the derivative of x squared is 2x, because you're using the power rule. And now you just do all your simplifying, you get that is 2x all over 2 times square root of x squared plus 1. The 2's actually just cancel here, and so you end up getting x over square root of x squared plus 1. Kind of running out of space here, but that right there will be your full solution. Alright, so here is the fourth problem, and as always, pause the video, try it for yourself first, and we'll go over it. So here the problem states y is equal to x over 1 plus x squared. So here you notice that it's actually a division between two different functions right here. So instantly you should probably know that we have to apply the quotient rule, which I have written down off to the side here because it's quite a long one to write. Anyways, it states that the derivative of two functions being divided together, u divided by v in this case, is equal to the function v times the derivative of u minus the function u times the derivative of v all over v squared. And so we can simply just apply that here. So in this case, our top part, our x is u, and our bottom 1 plus x squared is v. So what is v? It's just, here in this case, I'm just going to write it as x squared plus 1. It's going to be this multiplied by the derivative of x, and it's going to be all that minus our function u, which is just x, multiplied, let's go minus, it's supposed to be a center dot. Anyways, function x multiplied by the derivative of v. In this case, it's just going to be the derivative of x squared plus 1. And it's going to be that all over our bottom function, which is x squared plus 1. X squared plus 1, and it's going to be that squared. Oh, and it's supposed to be dy dx. And here we simply just solve the derivatives. What is the derivative of x in respect to x? That's just 1, so we just leave that as is. And it's going to be subtract x times the derivative of x squared plus 1. Well, 1 is a constant, so that's just going to be 0, and x squared is going to be 2x. Write that better, 2x. And that is still all over x squared plus 1, all squared. So now that is equal to x squared plus 1 minus 2 times x squared, still all over x squared plus 1 squared. And we can simply just simplify the top part. It's going to be 1 minus x squared. And it's going to be all that over x squared plus 1 squared. And that right there would be your full solution. So here is the fifth problem. It states that f of x is equal to e to the power of sine of x. And so you should probably already have noticed that this is another chain rule problem. And so in this case, our two functions, I'll say, no, I'm not gonna say f, I'll say u of x. Our u of x is equal to e to the x, and I'll call it v of x is equal to sine x. And so u of v of x is equal to e to the power of sine of x. And so let's just try to find the derivative of the whole thing, the derivative of f. So f prime of x is going to be equal to the derivative of e to the power of sine x. Okay, well, obviously, but like, so it's going to be e to the power of sine x, e to the power of something is always the exact same thing. That being multiplied by our v of x, in this case, is just sine of x. Derivative of sine x. So it's going to be e to the power of sine of x times the derivative of sine of x, which is simply just cosine x. And that would be your full solution. That is it for this video, and hopefully this video helped you understand how to differentiate harder functions and that sometimes require the chain rule. So this is the second video on my 3-part series, and in the next video I will be covering derivatives questions that are a bit more challenging than this one.